Hello and welcome to the walking talking topic on vectors, question number 3 with me, Mr. Barton. Right, what is happening here? We've got APB is a triangle, N is a point on the line A to P, and then we get some facts. A to B is vector A to N is 2B, and N to P is B. Now that tells me straight away that if A to N is 2B and N to P is B, then I might as well get this down. A to P, that's going to be 3B's. That could be important. Find the vector PB in terms of A and B. So I've got to start at P and I've got to get to B. Now I can't travel along this route because I don't know what it is, so I'm going to have to go the long way. I'm going to have to go from P to A and then A to B. But I'm going to write that down. P to B is going to be P to A. Then when I get there, I'm going to go A to B. How do I get from P to A? Well, I'm going against the grain here, against the way it's pointing. I'm going a minus B, and then I'm going a minus 2B, which is going to give me minus 3B's. It's just the opposite direction of that vector I wrote down there. Then when I get there, I've just got to hop across here from A to B, and that's just going to be positive A. So I get minus 3B plus A, or A minus 3B if you prefer. So there's your easy warm-up. We're used to this by now, and then they're going to mess us up with this bit. B is the midpoint of A to C. So there it is there. Now, does that give us any extra information? B is the midpoint of A to C. Well, that's probably going to tell me that that vector there's got to be A as well, right? If it's halfway in the middle, perfect. M is the midpoint of P to B. So that's split exactly in half there. Show that NMC is a straight line. Now, when you show something's a straight line, what you've got to do is you have to show that they have a common point. So maybe both of them starting at N could be a way to do this. And you've also got to show that the vectors joining N and M and N and C are parallel to each other. So if I can show that N to M is parallel to N to C, then I've shown I've got two vectors that both start at N. They both have the exact same gradient. So they have to be a straight line. So I've got to show they start at a common point and they are parallel to each other. So I'm going to find the vector N to M. I'm going to find the vector N to C. I'm going to hope that they're parallel, and then my job's done. So how am I going to get N to M? So I'm going to travel along things I've worked out to make life easy. Now I've already worked out P to B, and I know M's halfway, so that's not going to be too bad. So if I want to get from N to M, I'm going to come down here to P, and then I'm going to go up there to M. So let's write that down. So to get from N to M, I'm going to go N to P, and then when I get there, I'm going to go P to M. So N to P, well, that's just going to be B. That's not too bad. And then I'm going to go P to M. Now that's halfway of P to B, which I worked out at the first bit. So that's plus a half of P to B. Now, let's work out what that is. So I've got my B already, and I've got a half of what I worked out before, a half of minus 3B plus an A. Okay, going to have to be good at fractions here. So I've got B plus a half of minus 3B. Well, that's just minus 3 over 2B's. Minus 1.5B's if you prefer, but I like to keep the fractions in there. A half of minus 3B. It's got to be a half. Positive times a negative is a negative. And a half of 3 is just 3 over 2. And then I get a half of positive A. Well, that's just a half of A. Okay, now let's tidy that up a little bit. So I've got a B there, and I've got minus 3 over 2B. So I've got one whole B, and I'm taking off 1.5 B's. What am I left with? One whole B, add on negative 3 over 2B's. Well, I reckon if I've got a whole and I take off 1.5, which is 3 over 2, I reckon I'm down to a half minus a half B's. And then I've still got me half A's. Now notice how important it is to be good at negative numbers and fractions in vectors. Okay, so that's my N to M. Now I've got to get my N to P. So I've got to get all the way from N, I don't know where P's come from there, all the way from N over to C. Now, which way am I going to go here? Well, this looks quite a nice route. If I go up here, across there, and across there, that's not looking too bad. I think I know all those. So I'm going to go, let's write it down here, I'm going to go from N to C, and the route I'm going to choose to go is I'm going to go from N to A, and when I get to A, I'm going to hop all the way across to C. What's N to A? Well, I'm going the opposite way here, so that's 2B, so I'm going to go the opposite way, so it's going to be minus 2B's. And when I get there, I've got to get all the way across from A to C, so I'm going to be travelling an A and another A. So that's going to be 2A's. So I end up with minus 2B plus 2A's. Now I've got myself a few marks, but at no point have I shown here that NMC is a straight line. I have to show that these two things are parallel to each other. How am I going to do that? Well, let's take NC, and let's see if we can tidy it up a little bit. What happens if I take a factor of 2 outside there? So if I do 2 brackets, take 2 out of minus 2B, I think I'm left with minus B, and take 2 out of 2A, and I think I'm just left with A. Alright, now let's have a look at this one. Can I do something similar here? What happens if I take a half out of this? What am I left with? So if I take a half, factor of a half out of minus a half B, I think I'm just going to be left with minus B, because a half times minus B is minus a half B. And if I take a half out of a half A, again, I think I'm just left with A. Now, is that useful? Well, yeah, it's very, very useful, because that vector and that vector must be parallel to each other. They've got the exact same BA component. They've both got minus B and minus A. The only difference is that's been times by 2 and that's been times by a half. That one is 4 times as far as that one. But my job's done here, because all I need to do is put therefore NC and NM are parallel. And I've shown that because I've shown they've both got the same vector component there. And I'm going to put and both start at N. They both start at N. And if you've got two things that are parallel and both start at the same point, they have to be in a straight line. There's no way you can have N to M being parallel to N to C and them not being a continual straight line. So I can just finish it off with, therefore, NMC is a straight line. And that's a tricky vectors question, that. But as long as you're good at your algebra, and as long as you set things out nice and neatly, you will not go too far wrong.